It started out with graphing and then it went to functions. I'm doing FOIL to solve x. Next is the expressions. Now I have to see if x is equal to or greater than 3.
Hey guys, I just wanted to go over chapter 3.1 in Carnegie about radical functions. Another name for radical functions is a square root. Here in the blue graph, this is actually a graph of what a square root looks like. And in green back there, that is a radical function. Some people think like surfing, that's radical. So 3.12 A0 introduction, we need to do two things. Identify the characteristics by the domain and range of the radical function, and number two, x and y intercepts. So let me do a quick introduction for each of those and we'll do an example. So how do you find the domain and range? Well, if you, here in red, if you were in like say pre-calc or algebra 2, you can also find this algebraically by just setting the radicand, what's in the inside, greater than or equal to 0, there in red. But I'm going to kind of just teach you guys visually or graphically. So we're going to look at the graph. Number one, we're going to use graphing, and we're going to look at Desmos and the graphing calculator. Step number two, we're going to look at the domain. And the domain in a graph is just looking at the x-coordinates. That's just going from left to right. And the question I have here is what input values can be used? Remember, you cannot divide by 0. Okay, and we're going to on the graph, we're going to go left to right. And then our range, which is our y values, we're going to go from bottom to top. And there in green, I have a question, what answers or output values are acceptable? And my hint over here in light blue is if you look at the light blue, is that light blue? Okay, let's get light blue. Is if you look at the arrows, I don't know if you guys can see how many arrows I drew there, but we're going to go ahead and graph f of x equals square root of x minus 1. Okay, so let's just say I was doing this by hand. I just want to show you guys by hand. I could just make a table of values and think of nice numbers. So when I put in for the value of x, it's going to give me some kind of nice value. So if I put in 1, and I put it in over here, 1 minus 1 is 0, and the square root of 0 is 0. I'm gonna skip a couple of numbers, and I want to think ahead. I want to take the square root of a perfect square. So if I put in 5, x equals 5, 5 minus 1 is 4, square root of 4 is 2. You guys see that? And if I do something like 10, x equals 10, 10 minus 1 is 9, square root of 9 is 3. So if I go ahead and graph this, here I have 1, 0, and let's say this is 5, we'll say this is 2, so 5, 2, and then we'll say this one is 10, 3, and our graph's going to look like this. Okay, now it's not a straight line, it should be kind of curved. Hopefully I kind of show that. Now let me show you guys how to use that by using both Desmos and graphing calculator. So let's use Desmos. I mean having an iPad, and I just downloaded the Desmos app, or you can use any web browser. And I'm going to type in y equals, I'm going to look for my square root button, and then I'm going to type in parentheses x minus 1, close the parentheses. And if you ever want to get out of those parentheses, just go towards the right. Okay, and here's our graph. You can actually click on there. We said 5, 2, so there's that coordinate right there. Okay, come over here. There's my other coordinate right at 10, 3. Okay, so that's how you would use Desmos to get a visual of the graph. Okay, let's go to a graphing calculator app. I use this one over here called Graph and Calc 83. It is free. It is on the iPad. And then I'm just going to type in. So the square root button is there on the left side above the 7. So, but it is in orange. So I'm going to have to press second x squared. The X button is above the apps. So X, let's put that in parentheses. x minus 1. Okay, don't use the math operations in the blue on the far right. That would be wrong. Okay. And again, if you want to get out of inside the square root, which is called the radicand, you just press the right arrow. Okay, I think should be okay. I don't know what that is. And then I'm going to press, we don't have zoom on here, so I'm just going to press graph. Ignore those bunch of blue dots. That's from my stats class, and I forgot to clear that out. So again, same thing. Here's my graph. You have, oh, isn't that cool? So that's the hard part. It's not telling me exactly that point, but you can see it's relatively close to 1 comma 0. And then we go over here, and we said this was going to be 2. If you do, we should have done 2. That was a dummy. And then I think we said 5, 1. That's about 5, 1. And we said 10. So if you do 10, you could do there at 1. Okay, so that is using both the both two apps, Desmos and the graphing calculator on my iPad. All right, so how do you figure out the domain and range now with this graph here? Now, what I'm going to do is I'm just going to go ahead and put in a bunch of vertical lines. I'm not using the vertical line test here. All I'm doing is just kind of getting some points. And as you realize you're going from the left to the right, where does the graph start? Well, in this case, this graph starts there at that solid point at 1 comma 0. I'm going to erase these lines because we're going to use these later. So that number there in green is starting on the x value, so domain is going left to right, is starting at 1. Right here. And I'm going to use a bracket, which means it's including, or it's a closed circle. Now, as I go towards the right, what's the last thing it touched there was an arrow. Okay, if it touches an arrow, it does not matter if the arrow is above or below the x-axis. In this case, this is positive infinity. So comma, positive infinity. So in the purple box, I wrote down below interval notation. So this is not an ordered pair. This is just saying where are all the x values. All right, let's find the range. Range is going from bottom to top. Let's do the same thing. I'm going to draw a bunch of lines going horizontally this way. This is not the horizontal line test. Again, what's the first thing is I'm going up from bottom to top. The graph is actually going to hit. Give me a second. The graph is actually hitting the y value. Pay attention on the y number line at 0. Y number line at 0. And you're noticing that when you went up, the last thing you're hitting is this arrow. Well, this is going towards, again, bottom to top. We're talking about the y number line, the y-axis. That is now positive infinity. What does the domain mean? Basically, we could pick any number that's 1 or greater to put into our function. And the answers are going to be 0 or up to positive infinity. All right, let me copy this. So now that we have a graph, let's go on to how do you find the intercepts? Okay, so there's my graph. To identify the x and y intercepts, it says take the function, basically make your y equal to 0. So let's do this. So I have f of x equals the square root of x minus 1. So I'm finding the x-intercept here. Let's write this, x-intercept. We're making y equal to 0. Now this one has no y, so you're changing the f of x to that. And we said make the 0, y equal to 0. And now here we're just going to solve for x. I'm going to take the square root of both sides. And I'm going to get 0 equals x minus 1. And then we're just going to add 1 to both sides. And you're going to get x equals 1. So basically, what we found here is when y is 0, x is equal to 1. So in that case, that's for our example right here. Okay, let's do the second one now, the y-intercept. The y-intercept, we're going to make x equal to 0. Okay, so I have function here. Do the same thing, change f of x to y. That might make it easier for you. And I'm going to make the x value here 0. Okay. If you do this, you're going to get -1, and the square root of -1 is imaginary or complex. Let's write that. Imaginary or complex. And remember what that basically means is I'm graphing here on the real coordinate plane, x and y, and there are no i's there. So basically what we're going to say here is it does not exist. Does not exist. I kept getting confused on this when I heard of this. And you're going to see the initials D and E. And if you look back up to our graph, let's just graph this. This one is D and E. And you'll notice the graph hits the x-axis at 1, 0. But you'll notice the graph does not touch the y-axis, and that's why you do not have one. A y-intercept that does not exist in this problem. Okay? So in this quick introductory video, we found the domain and range of the radical function by just graphing it. And number 2, algebraically finding the x and y intercepts. That helps us verify on the graph. See you guys. All right, let's go ahead and complete A1, f of x equals the square root of 3x. You could just put that into the calculator. I'm going to press y equals up here. I'm going to press clear this out. My square root button, again, is in blue in this calculator, so I'm going to press second, square root 3, and then the variable x. If you ever need to get out, just press the right arrow. Because I have a Texas Instrument here, I can just press zoom, and I went standard, number 6. And what that does, it puts it on a negative 10 by 10 graph. So you can kind of see there it's already at the origin. So let's go ahead and sketch that graph. Use your favorite color. There's my graph. And I'm choosing to do this by paper, old school, is because I thought it was super helpful for you guys, okay? And because I get to use this. Okay, for domain, I'm going to go left to right. Let's write that. Left to right for the domain, okay? So I'm going to move my pen. As I go from left to right, the pen is not touching. Nothing, 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 nothing there. It touches the graph. Domain is the x-axis, so I'm starting at 0. So the domain is 0. Now I chose to use a bracket because it is a closed circle. And as I go towards the right, the last thing that it touches here is an arrow. Now it does not matter that the arrow is pointing up or down or above the x-axis or below. What's most important is that it's saying that we're taking all of these values on the x-axis, okay? So this would be towards positive infinity. So this one is going to be positive infinity. And always with positive infinity, always use a parentheses because it means you can't include one number there. All right, range is bottom to the top. So I'm going to move my pen now horizontally. I'm coming from negative numbers, negative infinity. And I go up here, it's not touching anything, not touching anything. Okay, now we're trying to focus here on the y number line, the y-axis. And on the y number line, the graph is starting there at 0 on the y-axis. And then again, as I go from bottom to top, the last thing I'm going to touch is actually an arrow. The arrow is indicating that you'll keep going towards positive infinity over here. Now with infinity, you normally don't write the plus sign, but I did on the previous example. So my two answers for domain or domain, here's my answer, and here's the answer for range. Let's go ahead and find the x and y intercepts. Fold my paper in half. I have the function f of x equals the square root of 3x. I'm going to change this f of x here into a y. And then from here, I'm just going to make the y value 0. 0 equals the square root of 3x. We are solving for x, so you can go the opposite of PEMDAS. So you simplify this direction, and then you solve going in this direction. So to solve, I'm going to do addition and subtraction first, multiplication, division, and then parentheses and exponents. There is no addition or subtraction. You might see multiplication here, but I have to use this exponent or square root first. So I'm going to go ahead and do the power of 2. Zero squared is 0. The power of 2 and the radical cancel, and I'm left with 3x. And I'm just solving for x. I'm going to divide by 3. 3 divided by 3 is 1 here, or cancels. In this case, cancel equals 1, so x is equal to 3. So you'll notice that the order pair is 3, 0. Just kidding. 0 divided by 3 is 0, because I was trying to think about it. Well, if x is 0 and y is 0, then on my graph, this is my x-intercept. Do you see it? This is where it crosses the x-axis. Let's find the y-intercept. So I'm going to do the same thing. I'm going to go ahead and change this to be a y. Now I'm going to go ahead and make my x equal to 0 in this case. So I have y equals the square root of 3 times 0. In this case, I am solving for y, so I will use the order of operations. There's no addition or subtraction. I'm going to do multiplication, division. So 3 times 0 is 0. And two identical numbers that multiply to be 0 are 0 and 0, so it's 0. So my order pair is 0, 0. And this is actually my order pair at the origin. So that actually means that in our graph, the x-intercept and the y-intercept are exactly the same for this problem. All right, in A2, we're asked to make a graph of this. Go ahead and make a prediction what you think that'll be. And let's do something different. Let's do the x and y-intercepts first, because I think that that'll help you get some clues for the graph before we actually just punch it into the graphing calculator. So I'm going to make the f of x, y. We're going to do a substitution. Y is equal to 0. And remember, to get rid of the square root, or the radical sign, you're going to have to take the power of 2. Why do you take the power of 2? Because the index is 2 right here. So then 0 times 0 is 0. 0 times 0 is 0. And then basically the exponents and the square roots cancel, and you're left with x plus 4. If I subtract 4, you get x equals negative 4. So the order pair is negative 4, 0. And if I actually put this on my graph, negative 4, 0, there's mine, negative 4. Let's go ahead and find the y-intercept, and that might give us a clue what happened to our graph. Same thing, f of x. And then I'm going to go ahead and change this to a y. we're going to go ahead and now make x equal to 0. Zero plus 4 is 4. The square root of 4 is 2. Two identical numbers that multiplied before is 2. This is a common mistake for students. When you take the square root, it actually, you don't have any more radical signs. So if you, let's just say you didn't know that, you can actually punch it into your calculator. The square root button again is down here. So square root of 4, the answer is 2. Okay? Notice there's no radical sign. So then my order pair is 0, 2. Let's do that in pink. Let's put it on our graph. X is 0, is 2. And I want you to see that basically what we did is you just sketched a graph right here. If you already know that all of the radical has basically a parabola that is rotated, is basically the inverse of the quadratic, and it just has a restriction. But this is what the graph looks like. Again, you can use Desmos or the calculator, and I'll just show you quickly on this one. So this one just says square root of x plus 4. To get out of that, you can just go out and then graph. And if you do have a calculator, you can also do this one, trace. There's the 0, 2 that we found, and you can go over here to where it touches the x-axis. I'm just pressing left. And the reason why that one says negative 4.09, because I couldn't get it exactly. Okay? You can also just second calculate zeros. But yeah, this is what ours, oh, we forgot to do the domain and range. Okay. Remember, domain goes left and right, so I'm going to show you with the pen. So the hard part is you just need to focus on just, for the domain, just this x-axis. So as I go here, I start on the graph, that number is negative 4. You do a bracket because this is essentially a closed circle. Remember, every point on the graph is a closed circle. And as I keep going on, the last thing I touch is an arrow. That means towards positive infinity. Always, always, always with the parentheses. Range is bottom to top, so I'm going to move my pen now. Nothing, 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 nothing. Now it's touching the graph. Pay attention. The range is the y-axis. So a lot of mistakes is that the students will think it's a negative 4, but remember on the y-axis number line, this is actually negative numbers, and that's 0. So we're actually starting at 0 here. And then the last thing we're touching is essentially an arrow. The arrows is talking about positive infinity, really big numbers. And this is our domain, this is our range, and we have the x and y intercepts. All right, A3. We need to find the domain and range of f of x equals the square root of x plus 1. We need to find the domain and range and x, y intercepts. But I want to start with these because I can kind of get some pillars or some key essential ideas for a graph without even using a graphing calculator. So I'm going to take this function notation and change it to a y. That's what it is. And did you notice that this plus 1 is not inside the square root? So if you think back to your transformations, this is towards the right. So pretend my finger is where the parentheses was. If it's towards the right, that's actually your d value. We're going to learn that later on about our transformations. That's just a vertical shift up. Now we're going to do our substitution. Y equals 0. I'm going to put out my silly chart again. And you go in this direction to simplify, but we're not doing that. We are solving. And as you go in this direction, basically we have to do addition or subtraction first. So you're not going to do the power of 2, you're going to subtract 1 from both sides. This will give you negative 1 equals the square root of x. There's no multiplication or division. Essentially, we have to do the opposites of these, so I'm going to have to use the power of 2. This is the opposite or undoing, so this is 1 equals x. Remember, there's a 2 here, so this exponent and this radical cancel each other in some ways, so 1 equals x. So when x is 1, when y was 0, x is equal to 1. Let's go ahead and put that onto our graph. 1, 0. All right, let's go ahead and do the y-intercept. I'm going to do the same thing. I'm going to change this to a y. I'm going to do my substitution. I highlighted the wrong thing. That's okay. You'll make mistakes like I do. Let's try that over here. This one is 0. And this one is still a y. I don't know how we make it a y. So y equals square root of 0 is 0. Again, use your calculator if you don't know that. And you get 1. So when x is equal to 0, your y value is 1. Let's go ahead and graph this y-intercept. So 0, 1. Okay, so let's go ahead and put it into our calculator. Remember how to get here. You're going to do y equals. And then I'm going to do the square root x. Okay, pay attention. The 1 is on the outside, so click right, plus 1, and then go ahead and graph that. Okay, so we made a mistake on ours, and you can notice it has a y-intercept. Let's go back. This is good. It's okay. We don't have an x-intercept, so let's check. 0. I'm going over here now. All right, for this one, I forgot to check for an extraneous solution. And basically what an extraneous solution is I need to back here at negative 1 equals the square root of x. Can you think of two identical numbers so that the end product is equal to negative 1? Can you think of any number? Can we put 1 back in there? Will that make sense? And it doesn't. So that means that there is no x-intercept. Okay, so definitely check for your extraneous solutions. That's just checking your answer. Okay, so we have a graph here. It's basically just a square root function shifted up 1 unit. Remember the domain goes from left to right. So the first thing I touch on my graph on the x-axis is not 1. It's actually 0. And remember here it is a closed circle. And here I'm going towards, remember, not because it's up, but because it's going in this direction, positive fade. So if you need to, in your beginning of your graphs, you can just write these negative numbers, positive numbers, negative numbers, positive numbers. And then the range goes from bottom to top. So the first number I touch on the y number line is 1. And I'm going towards positive infinity because the arrow here. So that means all the numbers are going to be positive there. And that's our answer for A3. Check your extraneous solutions.
I love that.
All right, A4, we need to find the domain and range, x, y intercepts. I have f of x equals the square root over 2. Again, if this helps you guys, helps me, you're going to simplify going in this direction, and then you're going to solve going in this direction. Okay? So I'm going to change this f of x to a y. And this is basically the same thing as 1/2. These are the same, so I just want to show you. So you can choose which one to work with. Some students choose to take the reciprocal, which is totally fine. Over here, you can also multiply by 2. So no addition or subtraction, so we're just going to do multiplication and division. And what you're doing is you're basically multiplying both sides by 2. We forgot to do our substitution as well. Sorry about that. So you have, so if you wanted to work with that one, you can. I'm just going to cross it off. 2 times 0 equals, okay, pay attention here. This one is cross-canceling. 2 divided by 2 is 1. So the canceling there is 1. You're just left with the square root of x. So I have 0 equals the square root of x. And to get rid of that square root, you're going to take the exponent, which is power of 2. 0 equals x. Okay, so what you have here is the order pair 0, 0. Let's go ahead and put that on our graph. And so as you're thinking about this before transformations, you got to think about what is the 1/2 going to do to my graph? Did I go left or right? Did I go up or down? There were no parentheses. There were numbers to the right of it or inside there. That's why I didn't move left or right. Let's find the y-intercept here. Same thing. Y equals square root of x divided by 2. This time I'm going to make x equal 0. So I have y equals the square root of 0 divided by 2. The square root of 0 is 0, and 0 divided by 2 is 0. So my order pair is x is 0, y is 0. And when that happens, you coincidentally have both an x, y intercept both at the origin, so you can't really see both the colors. Okay, so let's just try this without a graphing calculator. What number could you put in here to get a nice square root? Well, if you put in a 1 would be nice. If you put in a 4 would be super nice. Square root of 4. So if I go down here to 4, square root of 4 is 2, and 2 divided by 2 is 1. So this is where my graph's going to look like. Okay? And you can verify that with the graphing calculator. Let's go ahead and do that. Again, 2 separate ways to do this one. You can do square root of x. Oops, delete, go out, and divide your answer by 2. Okay, I want to prove to you that these are all the same. 1/2, so 1 divided by 2 times the square root of x. Kind of going fast because I think you've kind of seen all these calculator commands from me before. This trick I learned from another student. If you do alpha y equals, you have a numerator and denominator, so you can even do this one. Second square root x, go down, and 2. Okay. Now, to prove you to that these are all the same or equivalent, if I just press graph, what do you think is going to happen? You're actually not going to see 3 separate graphs. You're going to see the same graph because they're equivalent. See? All right, let's do the domain and range. I went ahead on my graph to go ahead and put in negative numbers, positive numbers, negative numbers, positive numbers. Remember, the domain is going left to right, and it refers to the x number line, or x-axis. And I chose to do this with paper and pencil by hand because I can't do this on my iPad. If I move along this pen, it's not touching the graph, not touching the graph. it's touching the graph here. Here's the question. What is our x value? Well, the x value is 0. And remember, you are using a bracket because this is a closed circle. Now, everything along here is a closed circle, okay? And as I go along left to right, the last thing I touch is this arrow. Now, we're looking at x values, okay? So that means it's going to keep going positive, big positive numbers or positive infinity. Remember, with infinity, you always use parentheses. Always. It means you cannot include one particular big number. It means you can pick 10,000, you can pick 10,001, you can pick 10 million. All right, range, you go from the bottom to the top, and it only refers to the y-axis. So if I go like this, nothing, 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 nothing here, what number is my graph touching on the y number line? That would also be 0. And okay, this one, the last thing you're touching is an arrow, but it's going towards this. We're saying that it's always going to, the graph's always going to keep going up to positive big numbers. So that would be a 0 to positive infinity. Okay, so here is our domain, here is our range, and there is our x and y intercepts. And what did that 1/2 really do? All I did was just a vertical dilation. We'll see you guys. Bye. All right, A5 here, we need to figure out domain range, x and y intercept. Let's go ahead and do the x-intercept first. I'm going to change the f of x to a y. We're going to make y equal to 0. And we're going to go ahead and solve for x here. Notice how there is no pluses or minuses. And again, if this is helpful, we're doing solving, which goes this direction. So there is no addition or subtraction outside or in front. Same thing with the multiplication. So I'm going to be doing the power of 2. So 0 equals negative 5x. Remember, the exponent here and the radical are canceling. So it's just left with what's inside the radicand, which is negative 5x. And then I'm going to divide. 0 divided by negative 5 is 0. Negative 5 divided by negative 5 is 1, or we write 1x or just x. So you have an x at 0, y is 0, so you have the order pair 0, 0. So my x-intercept here, right there on the graph. Okay? Let's go ahead and do the other side. We're going to do the same thing, f of x. Easier way of writing that is just the y. This time we're going to make x equal to 0. Negative 5 times 0 is negative 5. Okay, right here, pay attention. Duh. I wasn't paying attention. Negative 5 times 0 is 0, and the square root of 0 is 0. That's what I wanted to say. Pay attention, because don't make the mistake I did. All right, so if your x is 0 and your y is 0, then you have the order pair 0, 0. Where is the y-intercept? Oh, it's at the origin where your x-intercept is. What does that mean? The graph did not move left or right, up or down. Why? Because there was no numbers to the right of it for vertical translations. And there was no plus or minuses inside the radical. Okay. All right, let's go ahead and now complete the domain and range. Now, we don't have a graph, so I have a question. Back in transformations, I think we did it in 1.1. What did the negative sign do inside the parentheses? That was kind of like our b value. Now, if you don't know, that's okay. Just put in your graphing calculator here. And you can also make a table of values to get a graph. So I have the square root negative 5x. Okay, I wanted to show you this one, so I should have done that again. The negative sign is This is only for Texas Instruments. Casio's, those are a little bit better. But this is the negative sign and this is the subtraction sign. They are actually different. I wanted to go back inside X, parentheses, then go back out. Okay, and press graph. Whoa, the graph went the other way. So it reflected over the what? Y-axis. So my graph is actually going to look something like, ta-da! Here's the reason why, okay? Let's think of a number. Let's make a table of values. -5. If I put in -5 times -5 is 25, and the square root of 25 is 5. So you would get that number. That's why it's going that direction. Okay? Domain, well, okay, this is a little bit tricky. So you're coming over here. Let's list out all the negative and positive numbers. So those are negative numbers on the X, negative on the Y's, positive on the X, positive on the Y. So I'm coming over here. The first thing I'm touching is the arrow. Okay, the arrow, again, referring to the domain, which is the X values. You're coming from negative numbers. So that means you can pick any negative number, but you have to stop at what number? 0. And the range, check this one out. It's the Y. We're going to go from bottom to top. Nothing, 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 nothing. Stop. On the Y number line, that is 0. Okay, I'm going to include 0, so that would be a bracket. And then the last thing you're touching is the arrow. Okay, it does not matter where the arrow is. Okay, it can go to the left, it can go to the right, it can be straight up. It's just saying that the Y values on the graph are going to be going up, so we would just say positive infinity. So for A5, here is our domain. That should have been a bracket. Good thing I checked. Remember, that's a closed circle. And the range, there it is. All right, A6, we need to find the domain and range and the x and y intercept. But this one looks a little bit different. So what I'm going to do is, in math, it's okay as long as I'm going to change that into a y. But I'm going to put the x first with a negative, because x is negative and 3 is positive. You can do that on the other side if you want, because you're going to do the same thing. And the reason why I did that is to show that the negative sign, and then you have a +3 there. Or, this is just going to the future about a future lesson. If you factor on -1, you're going to have something like this. Okay? And that's just going to help you see the transformations. That's all. That's all I'm just pointing out. Okay? If you want to work with this one, you can, but you can also work with this one. We're going to make y equal to 0. And then I'm going to go ahead and remove the radical sign by going to the power of 2. You're going to have 0 equals negative x minus 3. I'm going to divide by -1. What that's going to do is cancel this negative sign, which is really there's an invisible 1 there, so that's gone. And 0 divided by anything is 0. So you're left with parentheses x minus 3, and you don't need those parentheses anymore. And then we'll just add 3 here. So I get x equals 3. Right, that's 0, and that's 3. Okay, now what I'm going to do is double check for extraneous. So just put in here 3. 3 minus 3 is 0, and the square root of 0 is 0. So that works. So 3, 0. 3, 0. Let's put that out. Again, that kind of goes back to our transformations. Add to x, go west. So you're going to add and subtract as you go, not left or west, you're going to go right. So that is 3. Okay? So same thing over here. You can work with any of these. I have it here, so let's just work with it.
That's what says y-intercept. We're going to make the x equal 0. Or I changed it. Let's put it here. So I have y equals, pay attention, opposite of 0 plus 3. Can you have the opposite of 0? No, you can't. So that would just be 0 plus 3. And 0 plus 3 is 3. Okay, here's not a trick question, but what are two identical numbers that multiply to be 3? It's a decimal, okay? So you can leave this as an exact. I'm just going to write there. So your order pair is x is 0. Y is the square root of 3. Okay. Let's graph that one. And again, you can put that into your calculator. It's just, I think 1.73 top of my head. Whoops. Second square root of 3 and 1.732. So that would be up here. And it's actually better. The only reason why I chose to do a decimal, I think that's actually not good. I think it's better having an exact. Okay. Now, if you realize in the last problem, what does that negative in the inside of the radical of parentheses, that's kind of like your b value, it's reflecting it over what? The y-axis. So your graph's actually going to look something like this. Closed circle here, going this way. Okay. Let's double check that, graphing calculator. You can put in the original. So again, square root, parentheses, 3 minus x, close it, and then go out, and then press graph. Okay. Again, it doesn't show it here, but that is a, whoops, that is a closed circle, and that's essentially an arrow. What do I have here? Domain goes left to right. So coming over here, I have negative numbers. That's where my graph is touching. So that's negative infinity. Always, always, always with parentheses and brackets. Okay, pay attention. Now this is the last thing it touches here, and that is a 3 on the x-axis. 3 on the x-axis. And it is a closed circle, so brackets. Range, we're going to go from bottom to top. Okay, nothing, 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 nothing. Okay, the graph is going to hit the graph here. Pay attention. It is not 3. Okay, you're looking at the range, which is the y number line, y-axis. So that is on the y-axis 0. So 0. And then the last thing you're going to touch is another arrow up here. So this is going to be positive, numbers positive, infinity. Again, what that means is you can pick any number, any negative number, up to 3, including 3, and your answers for the y's are going to be 0 all the way up to positive numbers. Okay, so that is our domain and range and our x and y intercept. All right, A7, domain and range, x and y intercept, and look at this one. We have something called a cube root. Before, if there was no number, there was a 2, but now it's specifically telling us it's a 3. So these are called cube roots, okay? But we get to do the same exact thing. Change it to a y. Substitute in the y equals 0. Okay, so how do you get rid of this one? It's the same thing, but you see there is a 3, so we're going to have to put it to the power of 3. 0 times 0 times 0 is 0. You're going to see that these go away, including the radical sign. And then you're left with 4x divided by 4. X is equal to 0. Okay? You can double check by putting this in to your original problem to check for extraneous. 4 times 0 is 0. 3 identical numbers that multiply to be 0 is 0. And that does work. So you have 0, 0 as your x-intercept. Let's go ahead and graph that. Okay, let's get our y-intercept. Do the same thing, change it to a y. going to do substitution. Four times 0 is 0. The cube root of 0. Let me put this, show you guys on my calculator if you need help. So my graphing calculator, it is under math and then number 4. So you can just click down and then enter or press number 4 and then put a 0 in there. That's 0. Okay. So x is 0, y is 0. Look at that. It is the same. Okay, so how can you get something in here? You could pick some numbers in here, such as this. Watch. Just do a x and y coordinate plane. Okay, table of values. You gotta think strategically. I'm gonna have to eventually take the cube root. Okay, so if I put a 2 for x, 2 times 4 is 8. The cube root of 8 is 2. Remember, the opposite of that is 2 to the third power is 8, which was in the inside, right? 2 times 4. Okay, so I have 2, 2. That works. Okay, so what would happen? Let's take a look at our graph. Okay, so again, I already have it, math, this number, and we have 4x in there. 4x, and let's just graph it. Okay. Wow. This graph here looks like a what? That kind of looks like a cubic function. Oh. I guess you're starting to make some connections. X to the third, if you somehow solve it, its inverse is the cube root. Here's the question. How do you go from there to there? Oh, we switch the x's and y's, which will be a future lesson. But let's go ahead and get the domain and range here. Remember, fill in all the negatives if it helps you, and positive numbers. Domain, we go from left to right. So I have an arrow here, so that's negative infinity. And another arrow, positive infinity. Oh, interesting. That one had 2 arrows going left to right. Okay, let's try this one. Bottom to top, okay. Okay, the first thing you touch is always going to be, if you see an arrow, it's going to be an arrow. So there's an arrow, and another arrow. So negative infinity to positive infinity. Look at that. Another one with 2 arrows, negative infinity to positive infinity. I think I see something for odd degree functions. All right, so let me highlight that. That is our domain and range. All right, A8, we have f of x equals the cube root of x minus 2. We're going to do the same thing. We're just going to change this to a y. You can start making some predictions. This minus 2 is in the inside. Back to our transformations. A future lesson. 0 equals the cube root of x minus 2. I want to get rid of this, so now pay attention. I'm going to have to do the power of 3. Why? These are opposites. Cube root and the power of 3 cancel, and you're just left with what's inside. So you're going to have 0 equals x minus 2. Add 2 to both sides. You're going to get 2 equals x. Okay? So when x is 2, your y value is 0. Okay, so there is our x-intercept. Oh, interesting. shifted over to the right. Instead of it being at the origin like the last problem, it's shifted over to the right. Add to x, go west. It's not adding to x, it's subtraction, so you go right 2. All right, let's take a look at this one. Let's do the same thing. Change the f of x to a y. Okay. Do our substitution. So I have 0 minus 2. So I have negative 2. Uh-oh. Can you find 3 identical numbers that multiply to be negative 2? Ooh. Okay, for now, we're just going to do this, okay? This is my answer. X is 0. And you have the square root of, cube root, sorry, of negative 2. Okay? Let's graph it, see what happens. Math, cube root, x minus 2. Close parentheses, get out of there, and then graph it. Okay, it looks like a cube root. Rotated 90 degrees, flipped around about the y-axis, but this one shifted over what? 2 units. Okay, let's go ahead and sketch that. Question from the last problem, do you think the domain or range would change? All right, let's think about this. Domain left to right. I have an arrow from here, negative infinity. Go towards the right, positive numbers, positive infinity. Range, same thing. Negative infinity to positive infinity. Whoops. There it is. Again, is there a trick or a pattern you guys see about the domain and range? Well, if you have an arrow, 2 arrows, they're going to be this. Okay? Think back to a linear, think back to a quadratic. It's basically just a power. Looks like the power functions, right? We'll see you guys. Bye. All right, A9, we need to find x, y-intercept, and the domain and range, okay? Change the f of x to a y. I'm just going to do it on both sides, save myself some time. Okay, we're going to take y equals 0. Use your highlighter, super helpful. Okay, remember this is not in the inside. So again, if you use my little chart PEMDAS and we're going backwards to solve, this is where we have to do this one first. Does that make sense? All right, add 5. That's 0. We're going to have to take the power of 3. Does that mean 5 times 3? No, that means 5 to the power of 3. So 5 times 5 times 5. Put in your calculator, you'll get 125. And you have x here. Okay? So when x is 125, the other part of the order pair is y equals 0. Okay? Pink, 125, comma 0. See, that's a good thing about having conceptual graphs or no number, like the little coordinates, the tick marks, because then you don't have to sit there and draw 125 of those. Does that make sense? All right. Let's do the same thing over here. This time is a little bit different. This is telling me make x equal to 0. Y equals 0 minus 5. The cube root of 0 is 0. Again, if you need help with that, look at your calculator, and 0 minus 5 is negative 5. So 0, comma, negative 5. Orange. Ooh. Look at this one. What do you think the graph's going to look like? Oh, look at this. This negative 5 is on the outside to the right. Looks like a D value. It looks like it's going where? Shifting what? Down. Let's double check. math, cube root, okay, x, okay, now go out, because that minus 5 is not there, minus 5, not negative 5. So it looks kind of like the cubic root, the cubic function, but shifted down, or the inverse of it. I mean, that's at 125, so, but, all right, domain, left to right, arrow, and it's not negative because this is below. That's not the reason why. Again, the x values are negative. And the last thing is another arrow. Range bottom to top, same thing. Arrow, the last thing you touch, arrow. Negative infinity to positive infinity. In other courses, they would have called that like all real numbers and all real numbers. But we're using interval notation. I like it because it tells you a start and an end. So there's my domain and range for A9. Bye-bye. Math lovers, let's go over A10. I have f of x equals the cube root of x divided by 4. Now, I actually like this one. Let's just say the problem was written like this. If I asked you to write a 1, where would you put the 1? You would write the 1 here. So in some ways, this is really 1/4 times the cube root of, sorry, that's an x, okay? So let's do the same thing. We're going to change this to a y. Substitute y equals 0. Zero equals the cube root of x over 4. Okay, we're solving for x. You can use my little chart, PEMDAS, and we're going this direction to solve. So there's no addition and subtraction. This is division divided by 4. So the opposite is multiplication. So I'm going to multiply both sides by 4. Okay, you have 4 times 0, which is 0. This one is 4 over 1. So these 4 divided by 4 is 1. You're left with the cube root, that's a 3, of x. Again, the next one is the square root, or cube root, and the opposite of that is to the 3rd power. So you're going to get 0 equals x, and when x is equal to 0, our y value is 0. Or you could say when y is 0, x was 0. So you get that order pair. Remember, the question you should be thinking about is, what do you think is going to happen to our graph? And I'm kind of going opposite. We're doing the x and y intercepts first because we're kind of giving puzzle pieces to the graph and getting something about our graph, okay? Same thing, let's change that to a y. We're going to do our substitution here. Three identical numbers that multiply to be 0, that is 0. Can you divide it by 0? I mean, something divided, 0 divided by something, yeah. And guys, this is like a common mistake for students. Put it in your calculator, okay? So easy to think 0 divided by 4, or 4 divided by 0 is the same thing. They are not, so pay attention. Okay, when x is 0, y was 0, and that is our y-intercept. Let's put it on our graph here. Okay, just think back to our parent function. Question is, what do you think happened with that divided by 4? It's really your a value. Get a graph. I'll show you a trick the student taught me is you can press alpha, then y equals. It gives you the fraction option, so then you can just press the math for x, press right to get out of underneath, or the radicand, press down, and then 4, and then graph. It looks like it did some kind of vertical compression because it's your a value, because because they're just, whatever your answer is, you're just dividing it by 4. Okay? All right, let's get our domain and range now. As I go from the left, first thing I'm touching is an arrow. Okay? Pay attention, this arrow is not referring here. We're talking about domain, which is the x-axis. So this is negative numbers to arrow positive numbers. Let me try something different. I'm always trying to show it to you a little bit differently, okay? Now, okay, negative, positive. Now we're going to refer to this darker blue line, okay? Nothing, nothing, nothing. I have an arrow. It's not referring to this, referring to bottom to top. So negative numbers touches to positive numbers touches. Okay, and remember, when you have two sets of arrows in both directions, you're always going to have that. So there is our domain and range for number 10. Bye. All right, A11 here. F of x equals the cube root of negative 2x. Let's change it to a y. Substitute y equals 0. And then I'm going to solve for x here. You'll notice that there's nothing in front. That would be multiplication. Nothing below, that's division. Nothing over here, plus or minus. So we're going to do the opposite, which is the power of 3. 0 times 0 times 0 is 0. This 3 and the little 3, the index with the radical sign, cancels. You're left with negative 2x. There's multiplication, do the opposite. 0 divided by negative 2 is 0, and you have x. So when x is 0, y is 0. There it is on a graph. Let's do the same thing for the other one, for the y-intercept. You're going to make x equal to 0. I'm going to change that to y. Let's do the substitution. Y equals negative 2 times 0 is 0. Cube root of 0 is 0. Again, feel free to use your calculator. Quit. Math. Put a 0 there. What's your answer? 0. X is 0, y is 0. Whoop, that's at the origin. Let's put it here. Question. What do you think that negative is doing to the graph? Well, think about this. If you pick something like, I don't know, negative 4. Just thinking of a number, so when I take the cube root, it's nice. Negative 2 times negative 4 is positive 8. The cube root of 8, 3 identical numbers that multiply together to be 8, the answer is 2. And that is nice because when you graph it, negative 4, 2, you have, your graph's going to do something like this. Okay? So I think that graph is going to look like this. Okay? Let's take a look at it. Let's take a look at it. Math. Number 4. Parentheses, because you have a bunch of stuff. Negative, okay, remember it's this button down here, and then 2x. Okay, close the parentheses, go right to get out, and then graph it. There's our graph. Okay? All right, domain goes from left to right. I'm going to write in all of those infinity symbols. I think it's super helpful. Where does my pen touch the graph? Right there at the arrow. This arrow is saying that all the x values are going to come from are negative. You can pick a negative x value. So negative infinity. Always, always, always with infinity, it's going to be a parentheses, always. So I'm going from left to right, and the first thing I touch is another arrow, which is positive infinity. You don't need to write positive. Range, first thing I touch is this arrow right here, so that is negative numbers. So the answer can be a negative number, or the answer can be a positive number. That's the domain and range for A11. All right, A12 here. F of x equals the cube root of 1 minus x. Let's change this one to a y. Okay, substitute it in. Raise it to the power 3. Remember, these out here, the 3 and the 3 with the radical sign cancel. You're left with what's inside, 1 minus x. Okay, pay attention here. Simple. I want x always to be positive when you're solving, so I'm just going to add x on this side. Think about that. X equals 1. So when x is 1, y is 0. There's my x-intercept. And remember, look at this one. That's to the right of the origin. So what do you think happened there? Let's write it a little bit differently on the y-intercept, and this should make sense to you. Remember in a previous problem, we changed the order. Totally okay. Commutative property of addition. And let's just say I wanted to factor out the negative. And I'm doing this again for a future lesson, but it's super helpful for you guys to see this. So if I factor out a negative, or negative 1 as your GCF, you're left with x minus 1. All right, you can distribute and check your answer there, okay? Why did I do that? You're going to see that this value is a negative, so it's probably going to reflect over the y-axis. And over here, you're going to see a horizontal shift. It's not adding to x, it's subtracting, so you're not going left, you're going to go right 1 unit. And that already proved my point. Okay? Let's change that to a y. It's okay to work with something a little bit different. Substitute in our x equals 0. Let's just solve for y here. Remember, my substitution, I'm always putting in parentheses. It got to be super clean and organized. Okay, so you're going to you're simplifying here. Okay, you're not solving anything yet, and everything's already on. Y is already solved for, so you're just simplifying. So you can use PEMDAS. 0 minus 1 is negative 1. Negative 1 times negative 1 is positive 1. The cube root of positive 1 is 1. So you're going to have 0, comma 1 as your answer. Okay? Let's do that orange. 0, 1. So it went up 1 unit. That's why did it do that? Well, we talked about how you already have that negative sign. So let's just work with the original. Let's pick a negative number that would work in here. Let's pick, remember, you have to think strategically. I want to pick an x value, so the opposite with the 1, well, you can easily find the cube root. So I'm going to pick negative 7. How did I get that number? Think about this. Negative 7. 1 minus negative 7. That's 1 plus 7. 1 plus 7 is 8. Cube root of 8 is 2. So negative 7, 2 would be something I can graph. So I think the graph will look like this. Okay. And let's double check that on our calculator. Dun, 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 dun. Okay, you could pick any of them. You could pick the original. Let's just choose original. Parentheses, 1 minus x. Close parentheses, right key, graph. Look at that. Look at that. Whoops, I forgot to, it's a cube root. got its tail. Doot, 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 doot. Okay. What do we got? So I go, domain is left to right. Okay. You stop when it touches the graph. Okay, what's the first thing it's touching? It's touching a arrow. Arrow will always be a negative or positive infinity, always. So in this case, although it's above, we're focusing on the x-axis. These are negative numbers on the x, so that's negative infinity. Always use parentheses. Same thing over here. Doesn't matter that it's going down. Okay, this is the common mistake. Students will write negative infinity because they think it's going down. The answer is no. It's a positive infinity because you still have positive x values. What's the big deal? It basically says you can pick any number, positive or negative, to put into this original function, and you can get a cube root function. Okay. The range works the same. So you have negative numbers, positive numbers. And I chose again not to use the iPad so I can show you the silly pen trick. Bottom to top. It's nothing, 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 nothing. It touches the graph. It touches a what? Arrow. That's the big idea. Arrows are like negative infinity. Negative numbers. And remember, not because it's going that way is it negative. We're focusing on the y-axis, up and down. That's positive infinity. So my answer can be any negative number or a positive number. That is the domain and range of A12. See you guys.